I'd like to welcome to the stage Satyam, the co-founder and CEO of Tiaro. And Satyam?
All right. Thank you.
I got to know Satyam last night, and I am very impressed, and I'm sure you will be too.
Thanks.
Thank you.
Yeah, now I'm going to put this on my resume. Can't turn on a mic. Stanford didn't teach me that. This is great, folks. Thank you, first of all, for having me. I'm, out of the Silicon Valley, so this is a very different world to me. I've been here, don't get me wrong, but always good to kind of come out, meet some friends. We've been some of us, we've worked together for more than 10 years now. Anyway, I found a little bit of what Aaron was doing funny. I think it was AI in action. Aaron taught me how to kind of do the slide change. So I'm going to very quickly try this. And this is how a model works. You rely on training, and now you can do a very simple task. And apparently, on this very simple task, people are kind of going bonkers, right? It's like, wow, you can change a slide. And so, that's where we are, frankly speaking. We'll get into it in a second. But anyway, I was kind of very honored to receive this invitation in the first place. But my first reaction, because I'm an engineer by training, was of concern, because I tried to visualize what this could have been if we had done this conference 5 years ago, right? And I imagine I would have stood out here and said, hey, it's time to mint some coin. That's going to be the next 5 years. And that wouldn't have aged well. I hope you guys are not recording. I guess you are. So this is not going to age well either. Or we could have kind of talked about NFTs. Same problem. This couldn't have aged well. Or maybe I could have taken a more conservative approach. We could have said driverless cars. That's the next big thing. Unfortunately, that didn't age well either. Or solar, clean energy. Well, that didn't age well either. So I feel an immense sense of responsibility here, and we'll see how this ages. We'll talk in 5 years. But I'm going to talk about AI, and I'm very confident that this is going to age well, because I asked AI if this is going to be worth doing, and it says yes. And so how wrong could that go, right? So here we are. I'll get into it in a second. As you can see, I'm stalling. But to get serious here for a second, I asked AI a very seemingly innocuous question. It did put an asterisk at the end, right? It says, AI is going to be revolutionary, but really it'll depend on, how we develop the technology and, what kind of compliance and et cetera, et cetera. And in fact, that seemingly innocuous last statement is what keeps me up at night as the co-founder of an AI company. It is not going to be easy. And we've done this for a few years now. And so I'm going to share my learnings about why it's not going to be easy and what we can do to potentially make it successful before it comes crashing down, just like the previous 5 slides, right? And so that's what my talk is about. But before I go into kind of what we can do potentially here, some history, right? I've been doing this for 7 years now, give or take. And frankly, we've spent the first 6 flailing around. Long time ago, we focused a lot on computer vision. And so you could detect cats and dogs in a picture and feel happy about it. It turns out, this is interesting. This is what is the basis of driverless cars, for example. And so clearly it is important. But the problem with this kind of technology is it is very, very narrow band, right? It is very good at doing a very specific thing. As soon as you show it something slightly different, it is not good at it, right? So for example, you can create a model to detect cats and dogs in a picture, or humans, for example. But as soon as you put it in a conference center like this one, and you show it the picture of a crowd, it only detects 20% of the humans in the crowd, right? If you try to use it for security, let's say you make a model which is very good at detecting faces. The same model cannot detect a person, for example, when they are not facing the camera. And so that has been the problem with AI, right? Which is, immense amount of progress but for very, very kind of niche situations. As soon as you expand the situation, it doesn't work. And so that was the story with computer vision. And so, we kind of sort of did it, tried it many times. Yeah, eventually we kind of lost, faith in it. And so then the community in general started focusing on NLP, natural language processing. And so this was about kind of analyzing human, just written and oral speech. This worked better. But the problem is, even this approach was very kind of shallow, right, to state it very crudely, because this could do things like it could detect what is the subject of a sentence and what is the, what are other things in the sentence, like does the sentence contain a place or some name or, some action and so on. And then based on that, you saw the proliferation of chatbots, right? Something that I hate personally. It's the kind of the worst use case of AI ever invented, because the first sentence, the first interaction that you have with the chatbot is your last interaction typically. At least that is the case for me. And so that's where this kind of technology kind of hit a wall, right? The brick wall. And then now we are here in the age of ChatGPT. This looks promising. I can tell you honestly, I'm very excited. I haven't seen something like this for the last 7 years. It is a Swiss Army knife, right? It can do a lot of things. Not as good as a specialized tool, but it can do a lot of things above average. And so that's very nice, because now that narrowband problem doesn't quite apply. You can, in fact, use it for many different things, and it seems to be interesting, useful. So that's where we are. And I don't know, I'm sure most of you guys have played with ChatGPT, so I don't need to describe that. But just so we are on the same page, here's my view of how ChatGPT works. And it's actually very simple at the end of the day, right? And there's two specific things that the large language model like ChatGPT does, or any other model that Aaron happened to mention earlier, Bard, et cetera, is it has some skills and it has some recall. And so skills are the ability to identify topics, for example, concepts, or it can identify emotions, or it can identify the language that you're using, and so on. Those are skills. It can translate languages. It can do 2 + 2. So, and so that's skill. And the recall is, facts that it remembers, rote learning, right? For example, I know that Taylor and Travis are a thing, right? So, that's a fact. And so there are many such facts. Typically these models learn from the internet, so they pretty much know everything that the internet knows, sadly. But that's a fact. And so, for example, now it can answer a simple question based on a true fact. Is if you ask it, how many Grammys has Taylor won? It does two things, right? It first does the recall part of it, which is it'll figure out from everything that it has learned, it'll figure out that, there was this Wikipedia page which mentions all the list of Grammys that Taylor Swift has won. And so it's going to use that fact. That's its recall. And then it's going to use a skill, which is it won't show you that table, but it's going to summarize that table for you, saying, 5 Grammys, 8, I don't know how many, but more than me, at least. So that's that, right? It's as simple as that. It has skills, it has recall. And there's no more to it than that. The great thing about ChatGPT is how many skills it has, or how much recall it has. That's the only big thing. It has way more skills and way more recall than any other model that was ever created in the past. And it's going to grow, as Aaron was kind of mentioning. So here's the rub, right? I mean, this is simple. We've used this. Unfortunately, it doesn't quite work in the enterprise, right? Because the recall part is the problem. Now, let's say if you were to take an enterprise use case, let's say you are the dark side of the force, and you ask a simple question about the Death Star, then that question needs to be answered by recalling things that the internet doesn't know, or at least that's what kind of the dark side thinks. But so it would answer a question based on, let's say, the Death Star product manuals. And so that's a problem, which is the recall that is built into all these LLMs that are public is not quite useful for answering enterprise questions because those answers are based on internal data. And so the way we solve that problem is, we add another kind of proxy for the recall. So instead of using the inherent recall, we add a search engine to it. And nowadays, the most popular way of searching, so now you can, for example, dump a whole bunch of documents into a search engine. I don't know how many of you guys have done search in the past, but Elasticsearch is a very well-known search engine that has been kind of very popular in the past. Now with AI, there is this new search engine, a new kind of way of searching called vector search, and so that's very popular. We won't get into details; it doesn't matter. But that's the box, right? And so now, if you put all your enterprise data together and front-end it with a search engine, which the model can use in real time to recall some facts about the enterprise, and then it can marry it with the skills that it already has. So that's kind of the basics of how these models are going to work in the enterprise. And this whole technology, this whole technique of kind of searching for documents and then feeding it in real time in the context of a question that you're asking, so that you can find some raw information, which then the LLM kind of polishes off. That whole technology is called Retrieval Augmented Generation, RAG. Too many syllables. I mean, we get paid by the syllables, I guess. More syllables, more valuation, that kind of thing. So that's where that came from. I would basically say glorified Google search, right? That's pretty much it. So that's what that technology is. And unfortunately, like if you look around, if you Google for this, you'll find 99% of the AI community is focused on it, and rightfully so, because we are in the early innings, right, of AI. So you've got to get this right. I mean, even getting a great search engine to kind of do a great job on enterprise data is going to be very hard. So don't get me wrong. People have to focus on this. The problem is, even after we focus on this, there's a good chance that we will all be disappointed with the results. And so here are 3 example questions that search-based generation of answers is not going to answer. And if you actually look at the questions, they are pretty simple. Like one of the questions is how many versions of Death Star exist? And we know there are 2, right? I mean, all geeks in the room. Hopefully you are all geeks. But it's very hard to answer this question based on search, because what is the probability that the search engine will find all the versions, based on those keywords, right? The keyword doesn't contain the number 1 and 2. So it's clearly not going to search for the version number. And so you better have some document which says list of Death Star versions. Otherwise, it's not going to find the right results. And that is the problem. You might have great documents, right? You might say, hey, here's the installation procedure for Death Star 1, or here's the operating procedure for Death Star 2. Here's how to keep rebels away from Death Star 3, and so on. But the problem is, there's no one document which says, here's the versions, right? And so the search engine better find all those 3 documents and then come to the conclusion that, feed it to the LLM. And then, of course, the LLM will do the right thing. It'll come to the right conclusion. It's 1, 2, and 3. But until you feed those documents, the LLM can't do anything, no matter how powerful it is. It can be 1 trillion parameters, that Aaron was saying. Doesn't matter. You didn't feed it the right data. So that is the problem. It's simple things. I mean, how simple are these questions? How to secure Death Star against the Rebel Alliance? And that's a simple question. It doesn't work, because the security procedure for Death Star 1 is very different from the security procedure for Death Star 2. And you need to have that context of what you are trying to answer to. And so I can go on and on. In fact, I'll take the 3rd question. This is a very kind of tricky one. The top security issues for Death Star. And it turns out the way you answer that is you realize that, look, this is a big problem-solving question. First, you got to look at all the incidents that are reported on that Death Star and classify them, whether they were security issues in the first place or there were some other things, right, like the soda machine not working. And then you take all the security issues, and then you reclassify them into some buckets, and some operational security issues, physical security issues, et cetera, et cetera. And then you count the top 5 buckets. And then you take those top 5 buckets, feed it to an LLM so that it can generate a nice looking answer. right? That's your top 5 security issues for Death Star. But the problem is, like you have to do this kind of, this is how humans work, right? We'll first search for all the incidents, then we'll classify them. And so that's how AI ought to work too. Unfortunately, that is not how the previous system works, right? It's a very simplistic system. It can search for things and give you answers based on search results. It won't do this. You have to do this. You have to do a search engine. You have to do a classifier. You have to do a code generator, which will kind of generate SQL-like code to kind of count things, right? In real time. And then you finally have your answer, and you prune the answers to the top 5. This is a very hard problem. And for what? Like such a seemingly simple question. Think about how hard things will get when you ask supply chain questions or tier 3 support questions. That's going to be 100x harder than this one, which is already 100x harder than the search-based problem. So this is the challenge right here. This is going to be the next 5 years, is we ought to take AI from what it is today in the year 2023, which is a search-based recitation of known facts, to this other phase where AI can actually do problem solving. It can take your task and it can understand how many steps it's going to take, one at a time, one step at a time. It can figure out the steps in real time, by the way. I mean, things ought to be harder, right, for us to make money. But in real time, it needs to figure out what the sequence of steps is, and obviously that sequence of steps is going to be different depending on the task at hand. And then in real time, it needs to figure out the mechanism to execute those steps and to get you the answer. That's how humans work, and that's how we would expect AI to work in the future, at least 5 years later. If we can't do that, I think we are talking about Bitcoin all over again. And so, I've been personally, my colleague is back there, but we've been personally working on that transition. We are very excited about that first box, right? That's what we are in right now. But we think, unless we kind of get to the second box very quickly, people are going to lose faith. And that's going to be the end of that. That's going to be the driverless car all over again. So then how do we do it? And so here's a thesis we are working off of. We are trying to create this software called a refinement agent. And I mean, without getting too technical about it, maybe the closest analogy I can use is, it's like a car mechanic. Is we are trying to kind of create a car mechanic, and we give it a bunch of tools. And so now we have changed the kind of way this software works is, now given a problem at hand, the task coming in, the mechanic's job is to figure out the first tool to use to solve the problem. Not all the tools, the first tool. And so it'll say, oh yeah, there's a car with a flat tire, so yeah, maybe I'll just raise it up. So I'm going to use a jack. And so it picks the tool, it uses it, and then it arrives at an intermediate solution to the problem, right? Now the car is raised up. The tire's not fixed yet. And so now, given that situation, the car being raised up, it goes back again saying, what's the next tool I can use? Is it the final answer, or should I do more here? I mean, clearly it's not the final answer. The tire's not fixed. And so it's going to pick another tool, the wrench now, and take off the tire, and so on and so forth, until it decides that this is the final answer. The tire's changed. It's not flat anymore. If it's not flat anymore, that's going to be the response that it gives back to the human. So the idea behind this machine is that the more tools you can give the machine, the more it can do. If you give it a blender, now it can also make smoothies, not just change tires, right? So that is the idea. And so now, instead of over-focusing on making LLM smarter, which of course, people need to do it. I'll get to that in a second. We can focus on how to extract the smartness in the LLM that we already have. LLMs already are smart enough to decide, given a situation, what is the next thing they might want to do. It's just that we don't leverage it, right? We instead leverage it like a search engine. Like, yeah, here's some documents, make up something. But if we were to actually give it, treat it like an adult, right? I mean, we talk about this with our children, right? If we give it a bigger challenge, it is going to answer the challenge. And think about it, right? To do this, you don't need recall, you need skills, which LLMs are good at, they are getting better, and so on and so forth. And so this is a skills-based problem, the refinement agent. It just needs to have the skill to make the right pick. It doesn't need to know what the tool does. It just needs to pick the right tool. It's good at that. So we are kind of very confident about it. And so now if you think about the problem that I talked about earlier, the top 5 security issues for Death Star, you can kind of lay it out in this manner, right? Which is, you can have some tools, the search tool, the classifier tool, the code generator tool for SQL, and so on and so forth. And now, iteratively, it's going to pick one tool after the other to arrive at the final answer. So this, I think, is going to be the next 5 years. This is not easy, by the way, right? But if we focus on it, I'm sure we'll get it. Just like how when people focus on creating an LLM, they got it. So, and the other interesting thing about this system is it's not just a pure AI problem. It is an AI and a data problem, right? Is when the refinement agent is trying to decide what it should do next, it needs to know what kind of enterprise data already exists. For example, it can't decide that I want to look at all the security, all the incidents that have been reported on Death Star, if you never gave it an incident database in the first place. So this is a very interesting problem which goes way beyond AI. It is a combination of kind of real-time data management and AI. Clearly the more moving parts we have, the less likelihood that this all works, right? Which is why we are working on it. But it is pretty interesting. And in fact, this is also interesting because now it also makes the playing field uneven, right? One would think, I kind of get reminded by the line in the Incredibles, is if everyone's super, no one is, right? And so if it was the case that the problem was as simple as every enterprise in the world being able to use an LLM and do simple search and feed it to the LLM, then everybody ought to do it, and everybody could do it, and nobody would have any differentiation. But now, if you can actually add the data angle, and if you can actually add the diversity of tools angle, now there's a lot of chance for differentiation. And the harder you work at it, the better you'll be. The harder you work on your data, the harder you work on your tools, the better you'll be. The LLM is not the only defining factor in the equation. So we are pretty excited about it, as you can tell from my very, very flat intonation here. And as you can see, I'm jumping for joy. But anyway, that's what geeks do. This is my kind of most joyful phase. So, if you believe what I said, from a technology point of view, this will lead to the emergence of a new layer in this whole AI equation, whole AI stack, right? So, and again, I'll explain it to you through an analogy that is close to my heart, because before AI, I used to do operating systems. And so in the operating system world, what we saw was, back in the 70s, 80s, people invented the CPU, and it was a very, very powerful invention. It was needed, obviously, people like Motorola, Intel, etc., Spark, Sun Microsystems. But the CPU, while it was an unbelievably amazing thing, it was very hard to use it, because the way to use the CPU is an instruction set. It can do a few things. It can do 2 + 2, etc. But it can't do interesting things, important things like manage CRM or whatever, run your website, right? It can't do that. And so people ended up creating an operating system, and it said, like, let's take this very interesting thing and layer it with some services that are more composite. And so then, with those composite services, people can build amazing things, right? So, the operating system took the CPU and then layered it with things like networking and storage systems and a scheduler, virtual machines, containers, all that nonsense. And now we can do amazing things, right? We can run email clients and web browsers and stuff like that. And so I think the same is going to happen in the AI world, which is, the LLM was a very important and necessary invention. It wasn't sufficient, or rather, it isn't sufficient. I think we are going to take the kind of that raw material, which is the LLM, and then layer it with an operating system, which can solve those very high level, it can give you higher level abstractions, that the refinement-based approach that I talked about. And then using the refinement-based approach, I think we can do some amazing things. We can do amazing things for customer support, customer success, sales operations, marketing operations, you name it, HR operations, etc. And so, we think that LLM OS is going to be the next 5 years, right? It's going to be hard. It's going to be a hard problem, just like how the LLM was, 3 years ago, before OpenAI and friends nailed it. So now, obviously, there are many, many different things this LLM operating system needs to do. I can't go into all of them. Most likely, I'll kind of, kill you of boredom. But, maybe I'll give you 3 examples. And you can kind of sort of extrapolate. And the reason I want to give you those examples is, hopefully as you try to use this technology for your own problems, et cetera, maybe you can look out for, some of these design patterns, right? And so that's at least my motivation for discussing these examples. And so the first one is LLM abstraction. So it turns out that when one uses LLMs, whether in this very kind of, fancy thing, refinement agent, or even in the basic retrieval augmented generation case, it turns out not all LLMs work the same way, right? And so it's like having kind of 5 different GPUs, graphic cards from 5 different providers, right? Anybody who has done gaming knows what I'm talking about. It's a pain to kind of manage the drivers and everything that goes with it before you can play your first game. So, the same problem is happening in the world of LLMs, right? Which is, if you give a task to an OpenAI model by specifying a thing, if you provide the same description to, let's say, an Anthropic model, the outcome will be slightly different. And the way you have to describe things are slightly different to get optimal outcome and so on. And so, our friend Microsoft has taught us a great lesson in the past. I mean, I don't know why I'm using a blue screen to kind of, maybe this is not going to work well. But anyway, let's try. So they created this thing called a hardware abstraction layer. And so back in the day, in the 80s, 90s, the problem was, there were hundreds of vendors creating network cards for the PC. And there were hundreds of vendors creating hard disks for the PC, and so on. There were 2-3 vendors creating CPUs for the PC, right? Intel, AMD, et cetera. And the problem was, all those pieces of hardware worked slightly differently, little differences. And so they created this layer called the hardware abstraction layer, which would provide one interface to the operating system on top. And then it would kind of negotiate all these differences. And so, for example, if the MLX card, the storage card, can do 1 gig Ethernet, but this other guy's card cannot, that's a hardware abstraction layer's problem, not the operating system's problem, and so on and so forth. And so that made it very easy and very quick for people above to create applications based on networking or storage or whatever else, because you didn't have to worry about those differences anymore. And Microsoft did, and in fact, they paid for it, right? Most of their crashes were because of the differences in hardware, which they were very proud to support, but there was a price to pay, which was the blue screen of death. And of course, they fixed it over the years, right? I mean, they made it nicer. Yeah, I love Microsoft. They made the problem more beautiful. That was their fix. But anyway, no, they had they were onto something. So, we think there is going to be a LLM abstraction layer that's going to emerge over the next few years. It's going to, and there are many reasons for it to emerge. And so, for example, now, as an enterprise, one doesn't need to, their functions, their software can be highly portable across, OpenAI, Anthropic, some open source LLMs, et cetera, Llama, et cetera, whatever you have, Bard. And so it is needed for portability, is needed for security and compliance. You can stop things at the LLM abstraction layer that you don't want the LLM to see or kind of sort of deal with and so on. You can obfuscate things before it goes to the LLM and so You can modulate things. Some LLMs can take a lot of data. Some of them cannot take too much data. So you can figure out how to feed a lot of data to an LLM that does not take enough data, right? Stuff like that. All of those things are the abstraction layers problems. So that's another thing you'll see emerging. And we are working on it, which is why the subject is very close to my heart. So just switching gears, let's talk about another topic, right? Which is, you'll see the emergence of tools. And it turns out, all the failures in AI that I talked about from the past, are now potentially going to be successes, right? Which is, in the past, we focused a lot on inventing highly specific models. Things, as I was saying, they were very good at doing a very specific thing very well, but they sucked at doing everything else. And so now you can take all those models, and it turns out the Swiss Army knife, right, the LLM, is the opposite, which is it is very good at doing a lot of, above average at doing a lot of things, but it is not great at doing a lot of things. It's master of all trades, right? Jack of all trades, master of none. The other ones are master of a trade, etc. And so now we can put it all together, right? Which is, there are, at last count, there were more than 100,000 models to do things like natural language processing and object detection and translation and so on. And by the way, this is a very hard problem. For example, and this is just one example, I can give you 100 more. There are more than 15 excellent license plate detector models. Because license plates all around the world look very different, right? So there is a Chinese license plate detector model that doesn't work in the US. There's an Arabic license plate detector model that obviously doesn't work in the US, and so on and so forth, vice versa. So that is the problem, which is even if you genuinely want to make a great license plate detector, you've got to understand diversity and kind of cater to it, right? And there's no point in kind of having your US license plate detector be very good at Arabic license plate. No one's going to use it. And so there's also a need to have this kind of very, very specific, extremely unique US specific license plate detector. And so these models are not dead. They were not useful so far. But now we can kind of cast them in a different light, right? Is what if all these models become tools? And so now the LLM, which is inherently not good at doing what a license plate detector can just offload that problem to a specific tool, the license plate detector, or a translator, right? The LLM obviously can recognize a lot of speech, blah, blah, etc. But there are way more translation models all around the world that are way better. There are way more vision models all around the world that are way better at doing vision than an LLM ever will be. So this is kind of the great opportunity here, which is you will see that a lot of tools themselves will be AI models. And then we'll live in this kind of universe where there is a orchestrator, if you will, which is the refinement agent, which by the way is based on an LLM. And then there are all these kind of orchestra elements, right? They are very good at one thing, and the orchestrator just happens to call them at the right time. And so if we can get to this is a self-programming computer, right? It has a lot of tools which are very good at doing a lot of different things. And then there is this one tool which is very good at calling them at the right time. And so, we talk about AI being sentient, etc. My bar is slightly lower, right? I think that is my version of sentient AI, right? Which is, it needs to be excellent. But, one thing cannot be, just like humans, right? One human cannot be excellent at everything. And so if we can actually set up this federation, it's going to be excellent at everything, but it's going to be a federation. So, and by the way, not to mention, but this might also kind of reinvigorate kind of research in this very kind of narrowband AI, which has now kind of gone wayside, right? Right now, most people in the community are focused on LLMs, but at some point, the pendulum needs to swing a little bit on the other side, towards the other side. More research has to be done on, say, forecasting models, right? So, or whatever, those forecasting things, supply chain forecasting, for example, is a problem on its own. You can't just assume that an LLM is going to solve it, and stuff like that. And the last topic here, last subtopic, is data. And so, for example, when you tend to, or you try to use LLMs in the enterprise, you have the opportunity to customize it a little bit. For example, the LLM trained on the internet doesn't quite know your verbiage, your terminology, tribal knowledge, so to speak. And so you can customize it. So you can, for example, customize it with all the products you are shipping and all the versions of those products and their acronyms, et cetera, et cetera. And that customization is typically done by a technique called fine-tuning. You give it a little bit of data, and then it'll understand that, oh yeah, got it. Death Star is a product, and there's 2 versions, and so on. It'll remember it. So next time, you don't need to supply those documents. You can just ask the versions. It has inherent recall now for a change, right? That's fine-tuning. But unfortunately, fine-tuning is of very limited scope because it can enhance recall, but it cannot quite enhance, the level of skill for the recall, right? And so we and the community in general are working on a different approach where, we kind of, the operating system, the intermediary, if you will, holds on to the recall. And when you do that, you have the opportunity to do a lot of things that the LLM just couldn't or never will, which is, for example, the operating system now can create intermediate artifacts off of your data. So for example, if you feed in product manuals, it can create an intermediate artifact that looks like a SQL table, which has product versions and product names. That was never in the manual, but the operating system has the kind of the sophistication to know that, look, in an enterprise use case, that is important, so let's do it. And then we can use it later in answering, right? So stuff like that. So there's just going to be a lot of work required to create, do that data engineering. And that data engineering has not been invented yet. A lot of the data engineering invented so far is around training models, but this is not about training models. It's about creating kind of, intermediate conclusions from enterprise data that already exists without ever feeding it to the LLM, in the hope that at some point you might have to feed it in the context of answering a question or in the context of using a tool to make the tool more productive, right? So there's going to be a lot of kind of research work required to make that green box. So anyway, I'll kind of stop with my kind of survey of things we need to solve. Simple things we are going to be done by tomorrow. But just to recap, right? We talked about 3 different things. How do we normalize LLM behavior so that the rest of the world doesn't have to worry about the disparity between LLM vendors and how they behave and how much functionality one has versus the other and so on. We talked about kind of reinvigorating the entire world of AI beyond LLMs by virtue of using already existing inventions as tools in this LLM world, in this refinement agent-based world. And then, of course, we talked about the importance of data and how we can kind of do a totally brand new generation of data engineering that hasn't been invented before. So a lot of work to do, hard to get started. If you do decide to get started on Monday, like Aaron said, then I would, I would, kind of suggest the following things, right? One is, we've seen a lot of ambiguity in even requirements. So people want to get started. In fact, they just jumped right in, and the requirements kind of follow, right? Unfortunately, they don't follow. And so it is better to kind of just have very clear requirements before jumping in. And then the same thing with data, is people just jump right in because, it is amazing. It's magical. Even if you do a simple thing, like feed in one PDF that you have, your favorite PDF, and it'll answer some questions, and you are very excited. But one PDF is not the total scope of the inquiry that all your users might use, right? And so it's very important to actually have kind of sign-offs that, look, we are going to provide the following data. In fact, that's where most projects break. Because as soon as now you try to provide mission-critical data, a lot of people show up, right? The CISO shows up, and so on and so forth. So it's not just an AI problem or a technology problem. There's just a lot of kind of thinking that has to be done to make data available for these projects. And same thing with quality, right? You've got to figure out what is your bar. Like, is your bar simple recitation, at which point you can use RAG-like approaches, or is your bar human-like problem solving, at which point you got to dedicate much more time, much more effort, etc., whether it's your own or working with a partner. And then finally, results, right? As you know, I've seen many companies having many AI teams, but there is no deliverable. And so this has the potential to kind of take away a lot of budget without a lot of results. That's how AI problems have failed for the last 7 years that at least I've been doing it. And so hopefully we don't do that failure anymore. And so results should be expected very quickly, even if they are starting results, right? And then eventually, obviously, you can build off of it. But the first result should be in a matter of days or weeks. And if it's not that, then something's wrong. So anyway, so that's a few kind of things to look out for. There's 3 different approaches you can take to kind of actually do it, right? So one is, I call it the IAS approach, which is bake your own cake, right? There is a lot of open source stuff in AI. There are open source models, there are open source frameworks like LangChain, etc. You can take all those things and try to build your own machine, the box that I showed you, if you have enough developers. In my opinion, the only people who should be doing that is people whose primary product is AI. Like we do it because we sell AI, the product. But if your product is not AI, in my opinion, you shouldn't be doing that. You shouldn't be baking your own cake. You should buy it. Then there is the second approach, which is the middle approach, which is, if the organization is really, really big, we are talking about, say, hundreds of employees or thousands of employees, then I recommend that approach, which is, you should think about AI as a platform problem, right? Which is, you have one database, and that database does many different things. It does things for marketing, it does things for sales, it does things for engineering, etc. And so you should have one AI which can do many different use cases. One AI engine, if you will, right? One AI product that does many different things. You have one data warehouse which does many different things, and so on. So, or one compute system, right? Whatever, VMware, Google, Amazon, etc., does many different things. And so you should have one platform that does many different use cases if you are a big company. But if you're a smaller company, then I think Burton was saying it, like, if all your life revolves around using Canva all day long, then, just use their AI, right? That's the SaaS approach, is, there is a specific piece of software you use, and that software vendor happens to put AI inside their software, and that's good enough. So if your world revolves around one piece of software, let's say Salesforce or whatever, Marketo, etc., then that's good enough. So that's kind of the 3 different ways, in my opinion. But most of all, it's important to just kind of get started, right? Because you miss all the 100% of the shots you never take. And apparently, things work out very well if you take one. So yeah, I would highly implore you to get started. If you want to talk more about, how to get started, etc., or, our own experiences, I'm around all day. So I look forward to it. But happy to meet you all. Hopefully some of us will talk more. Thank you.